Welcome to This Explainer. Today we're diving into Chapter 2, Sets. And we're actually investigating something you do every single day, probably without even realizing it. We're going to look at exactly how we take the huge, messy, totally chaotic world around us and organize it using a really incredible mathematical tool. By the time we wrap up, you'll be seeing the world in a beautifully structured, new way.
So, to get us started, I want you to just picture a really chaotic space. Maybe it's a messy bedroom, toys and clothes just scattered absolutely everywhere. Or maybe it's a packed shop with items piled super high on every single shelf. When you look at all that mess, how do you decide what goes where? How do you actually bring order to all that chaos? Well, you instinctively start grouping things together, right? You put the books on a shelf, the clothes in a closet. Without even thinking about it, you are already using the fundamental logic we're exploring today.
Think about a real-world example, like a local vegetable stand. A good vendor doesn't just throw everything into one giant, confusing pile. They intentionally separate their goods. The carrots go in one bowl, the green beans in another, pumpkins stacked neatly on the left, and maybe the lady's fingers all grouped together. Sorting things into clearly identifiable groups is just something we naturally do to make sense of things. It makes deciding what we want to buy and what they have for sale absolutely certain.
Section 1. Making sense of groups.
So how exactly do we translate that everyday grouping into an official mathematical concept? Well, the secret lies in absolute clarity. When a collection of things is undeniably clear and literally not debated at all, mathematicians call it a set. You basically have to be able to state with absolute certainty whether an item belongs to that specific group or not.
To show you just how versatile this is, let's look at a few examples. A set can be made out of almost anything, as long as it's clearly defined. The districts of the southern province of Sri Lanka? That's a set. The odd numbers between 1 and 10? Yep, that's a set. The vowels in the English alphabet? Also a perfectly good set.
Section 2. Meet the elements. Now, in mathematics, the items that actually belong to a set are called its elements. It helps to think of a set as a sturdy, clearly labeled box. The elements? Those are simply the specific individual items that you securely pack inside that box.
And what's really cool is just how flexible elements can be. They aren't just boring numbers. They can be physical objects, like vehicles registered in 2014. They can be living beings, like birds endemic to Sri Lanka. Going back to our province example for a second, the district of Gal is an element of the southern province set. But Kampaha? Definitely not an element.
Section 3. The subjectivity trap.
Okay, here is where we have to be careful. When we're defining sets, we have to look out for groups that kind of disguise themselves as sets, but actually fall into what I call the subjectivity trap. Take a look at this comparison. Even numbers between 1 and 10. That is completely clear. It's 2, 4, 6, 8. Boom, objective set. But popular singers of Sri Lanka? Well, that is totally debatable. Because math requires absolute certainty, groups based on personal opinions are subjective, meaning they cannot be mathematical sets.
Let's put this to the test right now. Think about the group Beautiful Flowers. Just pause and think about it for a second. Based on what we just learned, does this group qualify as a clearly defined mathematical set? Nope, you probably guessed it, because beauty is entirely an opinion. What you think is a breathtaking flower, someone else might literally think is a weed. Things like tall students or fortunate people also fall right into this subjectivity trap. Basically, if you can argue about it, it's not a set.
Section 4. Writing sets down.
So, mathematicians have a very specific way of recording their findings, and it's almost like a secret code. Here is the exact notation step by step. First, you open a curly bracket. Then, you write down your elements, making sure to separate each one with a comma. And finally, you close the curly bracket to seal the set. It's really that simple. But there is one absolutely crucial rule we have to follow.
The golden rule is this. The order in which the elements appear within the curly brackets is not important, and we only write each element once. So if your set is the numbers 1, 3, and 9, you can write them as 9, 1, 3. The order doesn't matter at all. Also, if an element repeats, you just ignore the duplicate. For example, actually think about making a set out of the letters in the word integers. There are 2 E's in there, right? But inside your curly brackets, you only write the letter E a single time.
Now, sometimes a set is just way too big. If I asked you to list out all the endemic birds of Sri Lanka, your hand would literally cramp up before you finished writing. That's why there are 2 accepted ways to write a set.
You can either list the elements out directly, like 2, 4, 6, 8, or you can just write down their common property, like even numbers from 1 to 10. Both are perfectly correct and universally accepted in math.
Section 5. Drawing Venn diagrams.
You know, sometimes it is so much easier to visually see a set rather than just read a bunch of numbers trapped in brackets. For that, we owe a huge thanks to the English mathematician John Venn. Back in the 1800s, he invented a brilliant visual way to represent these mathematical groups, and to this day, we still use his invention all the time. It's called, appropriately enough, the Venn diagram.
A Venn diagram is defined incredibly simply. It's just expressing a set by drawing a closed figure and writing your elements safely inside of it. So instead of drawing those curly brackets, you are using a shape, most commonly a circle, though honestly any closed shape works, to hold your elements securely in one place.
Let's break down the anatomy of a perfect Venn diagram. First off, you usually give your set a name using a capital letter like A or P. Second, you draw your closed figure boundary. And third, you write the elements clearly inside. So for example, if we had a set we called P for the square numbers from 1 to 25, we draw our circle, label it P on the outside, and write 1, 4, 9, 16, and 25 floating safely inside that boundary.
So, we've gone from organizing messy vegetables to understanding mathematical elements, dodging subjective traps, and drawing Venn diagrams. Now it's your turn. Look around you right now. What is one perfectly objective set of objects you can identify in your own room? Find a set, define its elements, and let us know in the comments. Thanks for learning with me on this explainer, and keep exploring those amazing patterns hiding in plain sight.